quick question. If you want to draw some function in real life, how would you go about it?
Well, let's see. If you are like most people, you're going to grab a piece of paper right here, and then you'll draw first some axes, let's say this and this, and then you will draw the data you want. Let's say I know the cosine, so go like this. Like here you have +1, and then -1, and then like this. Whoop. And then ideally you would label it, so here would have data x, and here data y, and then the title, I guess. And there we go, it's all good. We got ourselves a pretty basic, yes, but a sufficient plot. Well, turns out it's the exact logic to use to plot data in Python.
Where you have to set your figure to work on, then set the axis, plot the desired data on the axis, and then complete the plot with labels, legends, etc. Okay, so before we can see how to use matplotlib on Python, let's first talk about it. So matplotlib is a plotting library for the Python programming language and is designed to be as usable as MATLAB with the ability to use Python. Of course, it has the advantage of being completely free and open source. Now, pyplot is a matplotlib module that provides a MATLAB-like interface. So that's why you always see in scripts import matplotlib.pyplot and then LSPLT for the convention. You can see here a side-to-side comparison of a Python script and a MATLAB script, plotting the function we talked about earlier. As you can see here, the lines of code are very similar to each other, where here title becomes set title and x labels becomes set x label, and so on. In MATLAB, we don't work explicitly on the axis as we do in Python. In MATLAB, the commands are directly applied on the last selected figure. As you can see here, the plot was made on F2 and not on F1.
How to make this beautiful self-made plot with Python, like you can see here.
Okay, so here we are in our Visual Studio Code interface. Okay, the first thing we gotta do is to import our matplotlib library. So you're gonna do matplotlib.pyplot as, okay, the convention is PLT, like everybody uses, but I prefer to use plot. It's more aesthetic for me. And then now we want to create our X data. And to do so, there is one way to use there is one way to do so with the numpy library. So we're going to import numpy as n nop if you want, or np is the convention np. This will be equal to line space, sorry, np dot line space, starting from 0, ending with 30, having 300 values in total. So if we're gonna print out x, we're gonna see the following. Yeah, it ends with 30, starts with 0, and then there is 300 values. Okay, so we can reduce this again. Now we're gonna create our y data, which will be equal to np dot sign of x. And now we can plot our figure. Right. So to do so, we're gonna create a figure called figure1, which will be equal to plot dot figure, and then we can add the title of the figure. Let's say, oops, plotting with Python. We can also add the size of the figure, so we're going to do fig size, which is equal to a tuple of the height and width for 8. Okay. Now we're going to create our axis. So we're going to do axis equals figure1 dot subplot, sorry. Okay, now we're going to draw on our axis. So axis dot plot x and then y. We are going to add dashed lines like this, and we can also add a label. This will be used for the legend later on. We'll call this immortal signal. Okay, and we are going to display our plots. So plot.draw, and then plot.show, like this. Now we should have everything to plot our plot. Okay, so we run this, and yeah, there we go. You can see our sine function starting from 0, 0. Then this should be pi over 2, which will be equal to 1, and then in pi it will be equal to 0, and so on. Okay, this is the immortal signal. Now, let's try and create our decaying signal. So, the main idea behind it is to use the Heaviside function, which is a function that has a value of 0 before 0, and then after 0 it has a value of 1. It's also found in numpy, so we can do a help np.heaviside, and then we can comment out all of this because we won't be needing it for now. Okay, we run our code, and here you can see it's a help on the Heaviside function. So Heaviside of x1 and x2 is equal to 0 if x1 is lower than 0. It's equal to x2 if it's equal to 0, and it's 1 if it's greater than 0. So we can use this to manipulate a bit our sine function. And to do so, we can do the following. So first we gotta define at what x the decaying rate will start. So we'll set a new variable called a. We will set it to 15, for example. At x equal 15, the sine function will start dying. Okay. So we will create a dead function. It will be equal to np.sine of x, right? But it's equal to this until x reaches a, like this. After it reaches a, it will be equal to another function. So y will be equal to another other function. So one way to do so, we can, before we print this, we will use the npy.heaviside function of x minus a, so to shift it. Okay, and then x2 will be equal to 0. Alright, so now let's try and plot this to see. Okay, so now it's equal to 0 until it reaches 15, then it's equal to 1. Okay, but we want it to be equal to 1 until it reaches 15, and then it's equal to 0. So we want to flip this. One way to do so, we can just add a minus sign. We rerun after closing the figure. We rerun our code. Yes, so it's equal. It kind of looks like what we want, but it's shifted in the y-axis. So it's 0, then 15, then -1. Okay, so we just add +1, like so. We reclose this, and we re-execute. Okay, so now our function is equal to 1 until it reaches 15, and then it's equal to 0. So if we multiply this by, we multiply it by np.sin of x, we will get the following. You see, our sine function is the normal shape until it reaches 15, and then it's equal to 0. So now we gotta work on this part right here. Here, we will also be having another function which starts from 15. So it will be np.heaviside of x minus a, and then 0 of np.sin of x. So we're gonna print this again. If we do so, you will see that we will have the normal sine function. Okay, but here, from here, we will apply a negative exponential rate, which will decrease over time. So we will multiply this by np.exponential of some dying rate. To define it, we will do something like this. So it will be x minus a to shift it, and then over a. Okay, so I think this should be working. Yeah, like so. You can see this is our normal sine function, and at 15 it starts decreasing. If you want to see it decrease even further, we can use a new variable called d, d, and d will be equal to 5, which is rate of death. Okay, so we execute our code, and you can see now it's dying much faster. Okay, now we have our y_dead function and our y function. So we are going to plot both of them. And to do so, we already have our figure and the axis. So we just need to copy this because we want to draw on the same axis. Let's call this, no, actually, let's call this y, yes. And then this will be like this, and then we don't want to have dashed, but we want a color of black, and this will be our dying signal. Okay, now we can add plots, the axis name, title, and so on. So it will be axis.set title. Okay, so we are plotting the function y equals f of x, dying at x equals, and then like this, dot format a. Okay, and then we have axis dot set x label. We will call this data x, and then same goes for y, and y here. We can set an axis limit. So axis dot set xlim, which will be equal to the minimum of x to and a max of x, so that the point right here, so this is the minimum of x, this will be shifted right here, and the maximum of x, this will be shifted right here. So let me run this for now and see. Like so, you can see that it's starting from 0, which is the minimum of x, and it ends with the maximum of x. So we can do the same thing with y. So this will be y set limit, and this will be y. And here we will do max of y. We will rerun this code, and now you will see that it's aligned with the function. Okay, we can add a grid, so axis.grid, and we will add our legend, so axis.legend, like so, and we will rerun our code. Here you can see our legend, our grid, and the data y, data x, and the title of the plot and the name of the figure, which appears directly here. Okay, so now we will add a line separating the two functions, so we know at what point it's starting to decay. Like you can see, it's starting from 15. Here we are not seeing it exactly 15 because we don't have enough data points. If we took, for example, 3000 points and we rerun our code, we will see, yeah, here it's starting from 15 right here. Okay, let's make it back to 300. Okay, to draw our separation line, we will come down here. We will do a axis.plot of what? Let's come back here. We want to draw a line from here to here. So this point, this would be the first point, this would be the second point. So the x value of the first point is 15, and the x value of the second point is also 15. So this would be a. This is the x value. And then the y values, are this one right here and this one right here. So it's the minimum of y, which is this point, this point, and this point, and the maximum of y, which is this point, this, and this. So this will be min of y and max of y. Okay, it will be dashed, so we will make 2 dashes. Okay, and we will add a color of red. Color equals red. Let's rerun this. Now you see we have a separation line, but we want to actually add some text above this plot and this plot right here to know where it's starting. So to do so, we're gonna add a bit more space here so that we can write it here and here. So instead of setting the y limit to max y, we are going to set it to twice the amount. Okay, and this will be twice the amount as well. Okay, so if we rerun our code, now we have a bit more space to write. Okay, so to actually write text on our plot, we will be using plot.annotate, like this. It's the text we want to use, so we will say before decay, and then we are going to set the coordinates of it. This will be equal to So where do we want to place it? We can place it, for example, right here, or yeah, or right here, which, as you can see by the coordinates appearing here, it's 1.5 and 1.25. So it's a tuple. Let's do a tuple like this. 1.5, 1.25. And you also can add the size of 13. Let's say. Let's try and run this and see. Okay, so this seems to be good. And then we want to add another text right here. So we're just gonna copy this, and then we're gonna change this to after. The x value will be equal to 1.5 plus a with the same size. So if I close this and rerun it, you can see here we have the before decay and after decay. So yeah, so this is basically how we can use the matplotlib library to plot our Python data. So the most important thing to learn is this function right here. So axis.plot. So these three functions. And then you have the plot.annotate to add text to your plot. This is for a visually more pleasing plot. And yeah, you have a lot of parameters you can add, so label, color, and so on. So yeah, this was the video I wanted to make about Matplotlib. Leave a like if you liked the video, and subscribe if you want to see more content like this. And thank you for watching.